Welcome to the deep dive. We try to cut through all the noise, especially with tech stuff. It just feels like there's so much information flying around, particularly with networking. It can feel, well, pretty daunting trying to map it all out. So today we're doing a deep dive into the real foundational knowledge you need for designing and managing modern network solutions. And our source material is a bit different this time. We're actually looking at practice questions and explanations for an IT certification, the HPE7-A03 exam specifically.
Yeah, and our mission here really is to pull out the most important bits from these, let's say, technical scenarios. Think of it as a shortcut for you to really grasp the core network components, the security principles you absolutely need, and, the best practices that hold everything together today. We won't just list things off. We're going to explore why they actually matter, why they're non-negotiable for building solid digital infrastructure.
Exactly. So even though it's coming from an exam prep context, the insights themselves are super practical. Great for anyone just looking to get a quick handle on key parts of enterprise networking. Hopefully you'll get those aha moments without getting totally bogged down.
Yeah.
Okay, so let's unpack this. Where should we start? Maybe right at the ground level. Physical connections inside a building, like the actual wires and racks.
That's a great place to start because honestly, it's fundamental. And something often missed, or maybe not given enough thought early on, is the intermediate distribution frame. The IDF.
IDF. Okay, what's its main job?
Its main purpose is really to bring together all the user connections within a certain area, like a floor or maybe a section of a large building. Think of it as a local hub. It's a wiring rack, a distribution point. It connects end devices, your PC, maybe a printer, back to the main distribution frame, the MDF.
Ah, okay. So it's like a collection point before the main highway.
Exactly. And the key insight here isn't just that it organizes cables, though it does that too. It's really about making future changes or troubleshooting so much easier. It prevents that awful spaghetti mess and lets you scale things properly without that structure. Even small problems become huge headaches.
Right, right. Organization from the start prevents chaos later. Makes
Right.
sense. So, okay, you've got the cables run neatly through IDFs. Now, powering the devices, you mentioned VoIP phones earlier, voice over IP, they're everywhere.
They are, and for VoIP phones, the absolute critical thing for your network switches is having a sufficient power over Ethernet PoE power budget per port.
PoE, power over Ethernet.
Yes. These phones rely on PoE. It means they get their electrical power right through the same network cable that carries the data. No need for a separate power adapter at each desk.
Oh, okay. So no power brick.
Exactly. Imagine trying to plug in hundreds of phones individually. Nightmare.
Yeah, finding outlets alone.
Precisely. So if your switch can't guarantee enough power on those ports, you risk phones rebooting, calls dropping, just unreliable communication.
Yeah.
So a sufficient PoE budget isn't a nice to have for VoIP. It's essential. It simplifies everything.
Okay, so physical structure with IDFs, power handled by PoE. Got it.
Now, moving away from the wires, wireless, Wi-Fi. Huge part of any modern setup. But it's not just plug and play, is it? What's the very first thing you must do before deploying access points?
Ah, yes. This is where people often jump the gun. Before you even think about mounting an access point, the absolutely essential first step is doing a site survey to assess RF coverage, radio frequency coverage.
A site survey. Why is that so critical? Can't you just, put APs where you think you need them?
You could, but you'd likely be wrong, or at least inefficient. People often guess, or they just throw more APs at the problem, which can actually cause more interference. A proper survey analyzes the actual signal strength in the space. It identifies potential sources of interference, microwaves, other networks, building materials, and maps out exactly where the coverage is strong or weak. So it's like creating a heat map of the Wi-Fi signal.
Pretty much, yeah.
Yeah.
It tells you the optimal spots for your APs. Without it, you're essentially designing blind. You end up with dead spots, slow speeds, frustrated users. It's the blueprint you need for reliable Wi-Fi, no question.
Okay, blueprint first. Makes perfect sense. Now, you've planned your Wi-Fi layout perfectly based on the survey, but what about keeping it secure? An open network is just asking for trouble.
Absolutely. Security is paramount. And there are several key features here. First, you should definitely be using WPA3 encryption. It's much stronger than older versions like WPA2. Harder to crack.
WPA3. Got it.
What else? Then there's role-based access control. We touched on it, but often this is handled by tools like Aruba ClearPass. This is huge. It means you define who gets access to what based on their role or maybe the type of device they're using, not just an open pipe for everyone.
So different rules for different people or things.
Exactly.
Oh.
And another layer can be a master address filtering. You basically create a list of approved device hardware addresses. If your device isn't on the list, it can't connect.
Okay. MEC filtering.
And crucially, things to avoid. Open SSIDs networks with no password. Big no-no. Or disabling the broadcast of your network name, the SSID. That's not real security, it's just hiding and easily bypassed.
Right. So focus on strong encryption and controlling who gets on rather than just hiding. Okay. You mentioned ClearPass again, and you said this is where it gets really interesting. Moving beyond just connection to like intelligent control. Tell me more.
Yes, this is where Aruba ClearPass Policy Manager really comes into its own. Its core job is handling user authentication, proving who you are, and then applying that role-based access control we just talked about. Think of it as a really smart, centralized gatekeeper for your entire network, wired and wireless. It checks credentials, verifies users and devices, and then enforces the specific access rules or policies you've set up.
So it's the brain managing all those access rules centrally.
Precisely. But it gets even smarter. ClearPass can perform dynamic network access control based on device posture.
Device posture, what does that mean? Like how the device is sitting.
No, not quite. Posture refers to the device's security, health, or status. So ClearPass can check things like, is the operating system updated? Is the antivirus running and current? Does it meet certain company compliance standards? Before it even lets the device fully onto the network.
Wow, okay. So it inspects the device before granting access.
Yes. And based on that check, it can apply different policies dynamically. Maybe a fully compliant work laptop gets full access, but a personal phone that's out of date gets only internet access, or maybe access to fewer resources.
That's really powerful. It's not just about the user's password anymore.
Exactly. It shifts the security focus from just who you are to also what you are and how healthy your device is right now. It's context aware. This lets you build much more granular and adaptive security. It's a fundamental change from static rules to intelligent, real-time enforcement.
That really does sound like a leap. Centralizing the control, but making the decisions dynamic and based on real-time risk. That's impressive. Okay, let's zoom out again. Thinking about the overall network architecture. Building for performance, but also making sure it doesn't just fall over. Scalability and high availability.
Right. Crucial aspects for any serious network. For scalability and performance, especially in campus networks, a couple of things are key. For smaller to medium campuses, using a collapsed core architecture can be very effective. It simplifies things by basically merging the core and distribution layers of the traditional network design. Fewer hops, potentially faster.
Collapse core.
Yeah.
Simplifying the layers.
And definitely implementing VLAN segmentation and routing. VLANs, virtual LANs, let you break up your network into smaller, isolated broadcast domains. Think of them as creating separate virtual networks on the same physical hardware. This isolates traffic, improves security, and makes the network much more efficient. Less noise, better performance.
So segmenting the network traffic logically.
Exactly. Things you wouldn't do for scalability. Avoid redundant links. No, wait. You want redundancy, but you want smart redundancy. What you avoid is maybe single points of failure or just deploying a completely flat single-tier network. That won't scale well at all.
Right, avoiding bottlenecks and flat designs. Got it.
Yeah.
What about the resilience part? Keeping things running if, say, a main switch fails.
Yeah, high availability. That's where features like Aruba VSX come in, virtual switching extension. VSX essentially allows two separate physical core switches to act as one single logical device.
Two acting as one.
Yes. And they operate in an active-active mode. Both switches are actively forwarding traffic simultaneously. So if one switch fails, hardware issue, power outage, whatever the other one is already running, and instantly takes over the full load without any interruption to traffic flow. Seamless failover.
Ah, so no downtime during a failure. That's obviously critical.
Absolutely critical for business continuity. VSX provides that resilience at the core.
Okay, so we've covered design, architecture, security, resilience. What about managing all this day to day? And maybe touch on the business side, like proposing these solutions.
Good points. For ongoing management, a platform like Aruba Central is invaluable. It's cloud-based network management. It gives you things like real-time topology visualization. You can actually see your network map live and constant device health monitoring.
All from the cloud.
Yep. It centralizes monitoring and management, simplifies troubleshooting, gives you performance metrics, all through a single dashboard accessible from anywhere. It makes managing potentially complex networks much, much easier.
Like a command center for the network. I can see the appeal. And the business angle. When you're putting together a proposal, say for an RFP or request for proposal.
Ah, yes. Responding to RFPs, one of the most important yet sometimes overlooked parts is clearly stating your assumptions.
Assumptions. Like, what's your guess?
Not quite guessing, but defining the conditions your proposal relies on. Things you're taking as given unless told otherwise. For example, assuming there's adequate physical rack space and sufficient power and cooling where the equipment needs to go, that's a common one. Or assuming the customer's IT staff have the necessary training or will be available to help during the implementation.
Why is stating those so important?
Because it prevents misunderstandings down the line. It clarifies the scope of work. If those assumptions turn out to be wrong, like, oh, there's actually no power in that closet, then it's clear that it's outside the original scope and needs to be addressed, potentially at extra cost or time. It protects both you and the client from scope creep and sets realistic expectations right from the start. It's about managing risk and ensuring a smoother project.
Right, defining the ground rules clearly up front. Makes total sense. Maybe a final thought for you, our listener, to chew on. In this world where seemingly everything is connected, think about that idea of dynamically checking device posture with something like ClearPass. How does that capability, assessing the health of a device before letting it in, fundamentally change how we need to think about cybersecurity? Moving beyond just, passwords and firewalls towards a much more intelligent, adaptive kind of defense. Something to consider as you navigate your own information landscape.